Okay, I've done what they said. I've graphed it in Desmos. And we can see that the limit as x approaches 0 from the right should be negative infinity. So right now, before we use L'Hopital's rule, we're always supposed to check to see if it's indeterminate form. And if you substitute 0 into the right, you should get negative infinity. If you substitute 0 into, I think into the right, into the top, and then if you substitute 0 into the bottom, as x approaches 0 from the right, sine is getting closer and closer to 0. So that's not one of our indeterminate forms where it's negative, where it's like infinity over infinity or 0 over 0. So L'Hopital's rule isn't set up yet. I guess we can multiply the top and the bottom by x. But here, before we even use L'Hopital's rule, I don't think we need it. Look, we can do the limit as x approaches 0 of natural log x times cosecant of x. Because sine of x, 1 over sine of x is the same thing as cosecant of x. Okay, so I move this upstairs and then change it to its reciprocal so that it's still the same limit. This is the same expression, just written in a different way. Now, if we try to evaluate each limit separately using our properties of limits, this over here we said is going to be negative infinity. So the limit as x approaches 0 of natural log of x. And then the limit on the right as x approaches 0, that's 1 over sine of x that we're evaluating. And if x is getting closer and closer to 0, sine is getting closer and closer to 0. Sine of 0 is 0, right? So this is also going to approach infinity because you've got numbers that are really close to 0, like 0.00001. If you do 1 divided by 0.001, you've got infinity. That's a positive infinity. And then negative times a positive would make a negative. So that would be our answer.